In this video, I'll give an example of interpreting a multiple linear regression model, and I'm going to use the shipping example that we've used in some of the previous videos. So I'm going to go to R and load my data, and let's just remind ourselves of what it looks like. So we've got response variable y, or I've called it lab for labor hours, and then I've got 4 predictor variables here: TWS, PST, ASW, and num. And so we'll talk about the meaning of those predictors when we come to the interpretations. But to start with, let's just fit a model with all 4 predictors. So that's my model 1. And we've taken a look at this previously, but when I summarized model 1, I noted that 2 of the predictors had high p-values. So that raised a question in my mind: well, perhaps I don't need those predictors in my model. They're just adding noise to the model. They're not adding any understanding. They don't really belong, and so maybe I'll do better to exclude them from the model. So I fitted a second model that excluded those 2 predictors, and then we talked about this before, but a nested model f-test concluded that I was correct, that I didn't need those 2 predictors. They were redundant. And I can tell that because my p-value here, it's higher than, let's say, a significance level of 0.05. So I fail to reject the null hypothesis that says the regression parameters for those 2 additional predictors, PST and num, are 0. And so if indeed those 2 regression parameters are 0, then that implies that those 2 predictors aren't needed in the model, and I'm better off excluding them from the model. And so that's our working model here that we're going to use. It's model 2, and now if I summarize that, this is what I'm going to interpret next. So what we just did there was that nested model f-test. We did some model building, and we concluded, because of this p-value here, that there is no evidence at the 5% significance level that x2, which is PST, or proportion shipped by truck, or x4, which is weak number, there's no evidence at the 5% significance level that those 2 predictors provide useful information about y, which is weekly labor hours, beyond the information provided by the other 2 predictors, x1, or TWS, total weight shipped in thousands of pounds, and x3, ASW, average shipment weight in pounds. So then we come to model 2, which has just got the 2 predictors, and we summarize it, and we get a whole bunch of output. So this is a summary of all the output that I'm going to interpret, and in R, this is the summary that I get in R. And so it's all the same information, it's just formatted slightly differently. The only thing that's missing here is the confidence intervals for the regression parameters. So I don't have that down here, but I can get that using the convint function. So if I do that for model 2, let's spell it correctly. There we go. Okay, so then I can get the same information that's in this table. So what do all these pieces of output mean? Okay, let's focus first on this number here, this p-value for the predictor TWS. It's smaller than 0.05. So what does that mean? Okay, that means we found a statistically significant straight line relationship at a 5% significance level between y and x1, holding the other predictors fixed. We've only got one other predictor here, so holding x3 fixed. So in other words, we found a relationship between lab and TWS holding ASW fixed. What about this number here? This is the p-value for the other predictor. What does that mean? So that means we found a statistically significant straight line relationship at a 5% significance level between y and x3, between lab and ASW, holding x1 constant, holding TWS constant. These numbers, what do they mean? Okay, well, this first one is b0 hat, this one is b1 hat, and this one is b2 hat. So that means that our estimated regression equation is y hat equals 110.43 plus 5.00 times x1 minus 2.01 times x3. Okay, what about the meaning, the specific meaning for this number? So that's the y-intercept. So that would represent the expected value of y, or the expected value of lab, when the predictors are both 0, when TWS and ASW are both 0. So in this context, if we think about the definitions of the predictors, it doesn't make sense to have x1 and x3 both be 0, and so it doesn't have any practical meaning, this number. It's mathematically important to have it in the equation, but it doesn't have any practical meaning. What about the other two numbers? What about this one, 5.00? So that's the expected change in y in the response variable when we increase that predictor to TWS by 1 unit and hold the other predictors, ASW in this application, fixed. Okay, so now we've got to think about the definitions of the various variables. So that means we expect an increase of 5 weekly labor hours, that's y, when total weight, that's TWS, increases by 1 unit, 1,000 pounds, and the other predictor, average shipment weight, remains constant. And then that interpretation holds over the sample data ranges, which is the other part of this sentence here. And if we were to put a confidence interval around that number, then we would look at these two numbers here and say we're 95% confident that that increase is between 0.23 and 9.77. It's a pretty wide interval. We don't have a whole lot of data here, and the relationships aren't that strong, and so that's why we have such a wide interval here. We could also interpret this number in a similar way, okay, which is what this sentence is. So we expect a decrease, because this number is negative, of 2.01 weekly labor hours when average weight increases by 1 unit, 1 pound, and total weight, the other predictor, remains constant. And 95% confidence interval for that is between minus 3.42 and minus 0.6. Or in other words, the decrease is between 0.6 and 3.42. Okay, what else can we interpret here? So we could look at the regression standard error, which R calls a residual standard error, 8.815. So the way that we interpret that number is to double it. So we get 17.6, and then we can say that we expect a prediction of unobserved weekly labor hours from particular values of total weight shipped and average shipment weight to be accurate to within approximately plus or minus 17.6 with 95% confidence. Okay, it's giving us a very rough prediction interval. What else? What about R squared? What does that number mean? So the way to interpret that is to turn it into a percentage and say 80.8% of the variation in Y, weekly labor hours, about its mean, can be explained or at least accounted for by not wanting to imply any causality here, so maybe accounted for is a better word to use here, by a multiple linear regression relationship between y and x1 and x3. Okay, so that's an example of interpreting some of the output in a multiple linear regression model. I've focused on the numbers that are most relevant in the context of this course. So in the next couple of videos, just in the next video, I'm going to think about, okay, now we've got our model, we've evaluated its fit, we've assessed the assumptions, we've interpreted it, how do we use the model to estimate the expected value of y or predict an individual value of y?